Hey everyone, and welcome. Have you ever stared at a math formula and just thought, yeah, but what does it actually do? Well, today, we're going to pull back the curtain on one of the most important concepts in all of algebra, the quadratic function. We're going to cover what it is, what it looks like, and why it has a couple of different outfits it likes to wear. Let's just dive right in.
And that's the big question, isn't it? This little function is basically the mathematical engine running behind the scenes for so many things you see every day. You know, like the perfect arc of a basketball shot, or even the shape of a giant satellite dish. So to get how all that works, we've got to start with the basics, the formula itself. Okay, here it is, in what we call its standard form. At its heart, a quadratic function is just a polynomial where the highest power of x is 2. You see that little squared symbol? That's the real star of the show. That's what makes a quadratic a quadratic. Now, there are a few rules to this game. The a, b, and c are just placeholders for regular numbers. They're constants that give each parabola its own unique shape. But that x squared term, that's the one thing you can't get rid of. And that leads to the most important rule of all. A, the number out front, absolutely cannot be 0. Why? Well, think about it. If a was 0, it would wipe out the x squared term completely, and we'd just be left with a plain old straight line, a linear function, not our cool curve. So what happens when you take this formula and actually graph it? You get this really beautiful, perfectly symmetrical U-shaped curve. And this distinct shape has a name, a parabola. Every single time you graph a quadratic function, this is what you're going to get. No exceptions. All right, so that leads to the next logical question, right? If it's always this U shape, does the U always open up to the sky, or can it open downwards too? And more importantly, how can we tell just by looking at the formula? And the answer, believe it or not, comes right back to our friend, the a value, that coefficient in front of the x squared term. It's basically the director of the whole show. If a is a positive number, the parabola opens upward. If a is a negative number, it flips completely and opens downward. It really is that simple. And here's a super simple way you can remember that. Think of a positive a value as being, well, positive. It creates a happy, smiling parabola. And on the flip side, a negative a value, well, that's a negative vibe. It gives you a frowny face. It's a silly little trick, but trust me, it works every time. Okay, so that standard form we started with is fantastic. It's our default. But it's not the only outfit a quadratic function can have. You see, depending on what piece of information we're trying to find, we might want to write the function in a way that highlights something different. And here are the two main outfits you'll see, standard form and vertex form. Now, it's super important to remember, they're the exact same function underneath. They're just dressed differently. Standard form is great for quickly seeing your a, b, and c values, which is super useful for other things like the quadratic formula. But vertex form? Oh, it has a very, very cool trick up its sleeve. And that trick is really its superpower. Vertex form doesn't make you work for it. It literally just hands you the coordinates for the single most important point on the entire parabola, the vertex. So what is the vertex exactly? It's the turning point. It's the absolute bottom of the valley in a smile, or it's the absolute peak of the mountain in a frown. It's the one spot where the curve stops going one way and turns around to go the other. And we represent it with a coordinate pair, h, k. So, finding this point from the vertex form is incredibly easy. The h and k values are sitting right there in the equation, just waiting for you. But, and this is a big but, there's one little trap you have to watch out for. See how the formula says x minus h inside the parentheses? That minus sign is key. It means you have to take the opposite sign of the number you see for your h value. So if you see x minus 5, h is positive 5. If you see x plus 5, h is negative 5. The k value, though, he's easy. You just take him exactly as he is. And this quote right here, it just sums it all up perfectly. Using vertex form isn't just about finding one point. It's about instantly seeing where that vertex is, which tells you how the whole parabola has been shifted left, right, up, or down on the graph. It just makes visualizing the whole thing so much more intuitive. So we end on this question. Why on earth would we learn two different ways to write the exact same thing? Well, it's because each form gives you a different tool for a different job. Standard form is perfect if you need to solve for where a projectile is going to land. But vertex form? It will instantly tell you the maximum height that projectile will reach. Understanding both of them gives you a complete toolkit to really analyze all those parabolic shapes that are all around us. And that right there is a really powerful thing.